Hi, this is Jim Weaver, and I'm a Java Technology Ambassador with Oracle. And today I'd like to talk to you about what's new in JavaFX 8. I'm going to go through some features that are in JDK 8 with JavaFX 8. First of all, we're going to talk about this new modern theme that's in there. It's called Modena. Also, there are several enhancements to some of the core components of JavaFX, for example, collections, binding, tasks, and services. Also, there's some full-screen improvements, some other improvements like stage styles, swing integration improvements, rich text, and even now a printing API. A couple of new controls have made their way into JavaFX 8. One is date picker, and another is tree table view. Also, there are some enhancements and actually a public API for CSS now. And there are some WebView enhancements. WebView is the embedded web browser that comes with JavaFX. That's a WebKit port that is HTML5 compatible. Also, new to JavaFX 8 is JavaFX 3D. And a related thing that is not exactly new to 8, but is very related to JavaFX 3D, and that's multi-touch. I'm actually going to be demonstrating from and presenting from a Windows 8 tablet. It's a Surface Pro, and I'll be demonstrating some multi-touch things on that in conjunction with 3D on this. Also, very relevant to the Internet of Things is Java embedded support in JavaFX. So first of all, the Modena theme, it's a new modern theme for JavaFX. You may recall that the theme used to be Caspian, but now the JavaFX engineers and design engineers, led by Jasper Potts on the design front, has created a new theme called Modena. Here's an example. This is an application that you can use to experiment with the different colors of backgrounds and base colors. And you'll notice that when you change, for example, the base color, that the colors of the components change as well. That's because Modena does a lot of the work for you in selecting colors that look good with the base colors that you're creating and look good with each other. And even when you're putting components in other components, they attempt to size well and remove borders and things like that to look good together. So this Modena application actually comes as a JavaFX sample that you can use then to help you with application development and styling. You can always change back to Caspian if you'd like. We don't recommend that, but here's the code that you could use to change back to Caspian. Also, you could create your own theme and pick your own theme and use that code to select that theme. There are some charts using Modena, so you can kind of look at the way that those look and feel. Another thing that's related to JavaFX 8 is called Scene Builder 2.0. And the reason why it's related is because it's got a fresh new look from Scene Builder 1.0. In Scene Builder, you may know that you can create user interfaces by dragging and dropping controls and other UI elements into the scene. And so in this particular example you're looking at, we've created an application that monitors temperatures. So I'm going to show you an example of how you can use Scene Builder to create a user interface. So first of all, I'll go ahead and drag some component in here, some container, for example, a tab pane. And maybe I want to name this tab pane temperatures. And then perhaps I'd like to drag a chart into that like we saw before. So here's some charts down here. Maybe I want a pie chart. So I'll drag that in there, and I'll fit that to parent, make it nice and big, and we can view some sample data, and then we can see our pie chart. So it's really easy to drag and drop user interface controls into the scene, and also we can inspect different properties of the different UI controls that we put in there, and then even associate code with them. It works in conjunction with your IDE. The scene builder actually creates and edits a dialect of XML called FXML that expresses the user interface. And then the code that you create in your IDE works with that expression, and has annotations that can tie the two together in a model view controller fashion. Now I'd like to talk about some core functionality that's improved in JavaFX 8. And I'll do this rather quickly because some of it's not so visual, but we have some new and enhanced collections, including an observable array, a filtered list, and a sorted list. Also, in another session in the JavaFX 8 videos, Brian Gitz talks about lambdas and collections and the power that we have there with lambda expressions. And so the default method supported in Java 8 is something that Brian talks about, but we're using it in the observable list to expand it and make it more useful. So, for example, we can create a filtered list. Here where we've got an observable list. We're creating an observable array list with some items in it. And then we're using this filtered method that's been added to an observable list as a default method. And then we're passing in a lambda. This lambda expression uses a thin arrow. Here is where we're passing in the argument, and here's the function part of the lambda. So to demonstrate what's going on there, we have this, and as I'm typing, then it dynamically filters the list. So this slide shows a practical example with table view of the filtered list. That's the demo I just showed you, and this is the code behind it. And there's the output. Also, we have something called an observable array. Now, observable arrays are something that were added for JavaFX 3D. We needed another type of observable structure that would be very fast, that could hold a lot of 3D data for triangle mesh support. And so here are some of the basic methods for the observable array. Also, we can easily now create copies of observable arrays by using this copy to method. And as I mentioned, observable float arrays and observable integer arrays are used by JavaFX 3D APIs, and that's why they were added. There are also some binding enhancements. Binding is where we can keep, the biggest use case for that is to be able to keep a UI, the attributes of the UI, and a model in sync. So there are some enhancements to binding. For example, we can bind two observable lists together and keep them bound by using a new method called bind content of the bindings class. Also, there are some task and service enhancements. Tasks allow you to do some things concurrently, and services then manage several tasks. For example, we can now provide intermediate task results while the task is occurring by using something called update value. The code that you see here is behind this demo that you'll see. So when I press the activate mind reading algorithm, you'll see that the update value method updates the value so that in the task so that it can be seen immediately. So every 3 seconds, we see the words "you are getting sleepy" added. Scheduled services manage one or more tasks, and then you may need strategies, for example, in a network kind of situation where maybe there's a failure, and so you need a backup strategy to know how often to try to reconnect. And so there are several methods now for being able to do that. For example, this backup strategy, logarithmic backup strategy, is one that you might choose. So now back to some graphical things. We've got some improvements, for example, in full screen. You might have a kiosk, for example, that you want to be able to manage and not allow somebody to get out of. Maybe the kiosk is in a mall or in a dealership. And so when that comes up, it may require a keystroke, because you just saw that it said press Control X or touch the screen to exit. So we could restrict it to being able to just press Control X, and that would allow it to get out of full screen. Also, here's the code for that, and we can give them a full screen exit hint, so that's why the Control X or touch a rectangle message came up. And then here we're setting the full screen here. And then here we can prevent any key combination from exiting by saying key combination no match on set full screen exit key combination. That way the user cannot leave full screen. Now we'd like to switch gears and talk about a new stage style. It's called the unified stage style. And in the title area, in addition to just having a title, you can also have controls like we see here. And so you can use that stage style to be able to mimic some modern UIs and windows that you see sometimes with ribbons and other things in the Mac user interface. And here's some code that you can use to do that. Most notably, this init style, stage style unified. There's been some improvements in Swing integration. For example, if you'd like to migrate from Swing to JavaFX, in the past you were able to have your Swing application, and then if you'd like to, put JavaFX nodes in your Swing application. Or with JavaFX 8, you can do the reverse as well. You could create a new JavaFX application and then put Swing nodes into your JavaFX application. And by using one or both of those strategies, you can migrate over time from Swing to JavaFX and not have to do it all at once. To implement that, we have something called Swing Node. And that's how you can put a Swing component into a JavaFX node. You use something called a Swing node. Here we're creating a new instance of a Swing node, and then we're setting the content of that to in this case, a J button that we've created. In order to do that, because you've got two different threads, we need to use things like platform run later to be able to accomplish this feat of being able to have JavaFX and Swing coexist in the same application. But now with this flag here, JavaFX.embed.singleThread equals true, we can treat it like it's in the same thread. So in this case, the EDT equals the FX thread. Also, we have rich text support in the form of text flow. Here's some examples of rich text where we can mix different styles of text, different orientations, and even put controls and images in there. Here's an example of an application that uses a text flow, and I'll go ahead and show you this application. This is one node here. This is one text flow node. And notice as I stretch it, it comes on one line. but the code behind that is here. So we're creating a text string, or a text out of a string, and then we're setting the font to it, and then we're creating another text, and then we're setting the font, fill color, etc., and then we're creating a new text flow, and then setting both of those text objects into the constructor of the text flow. And that's how this example was created. Also, JavaFX 8 has a printing API. Here's an example of printing rich text. So we get our default printer, and then we create a page layout, and then we create a printer job, and then we can put settings into our print job, and then we can print page, and then if we're successful, we can end the job. So we have a public API for CSS so that somebody could create custom CSS styles. So it was required for Scene Builder because it required a public API for CSS access. And so that's a very key feature. Styling is a very key feature of JavaFX and carried forward in JavaFX 8. WebView, the embedded browser in JavaFX, has some enhancements. One is WebSocket support, and then another is web workers support, the ability to do work on behalf of a web application. And then we have some controls, most notably the date picker, and that uses the new Java Time API, the JSR 310, that was carried over from and improved from JavaTime by Steve Colburn. And so the date picker uses that Java.time, that new date time API. This is a graphic that shows the date picker. So here's an application, a very simple one that uses a date picker. This is the appearance before someone selects it. This is the appearance after. So then they can select a month or a year and then pick a particular date, and that populates the date picker. Some simple code for that. We create a new instance of a date picker. And then we use a lambda, passing a lambda into the onAction method. And then we use the getValue method of the date picker, and then we store it into a local date, which is part of the new date time API. There's more information about the date picker and some of the other concepts that I just talked about and the date time API on my blog. It's javafxpert.com. Another control that was added is called a tree table view, and that combines the tree view with a table view so that you can expand and contract in a tree fashion different rows, and each one of those nodes, the rows, can contain multiple columns. So it combines the best of both in a tree table view. As I mentioned before, JavaFX 8 has 3D now, and I'm going to talk about that in conjunction with multi-touch because those things go together pretty well. So I'm going to talk about the touch gestures, swipe, scroll, rotate, and zoom, and then talk about a lower level thing that we have in JavaFX called TouchEvents. And each touch event has touch points. But let me give you a brief introduction to JavaFX 3D. There are 4 different touch gestures. Those are all subclasses of gesture events. Those are rotate, scroll, swipe, and zoom. So a swipe gesture is where you can either use your mouse or your finger and swipe left, right, up, or down. And so here's an example of that. And here's the code behind that. We're creating a translate transition, which is an animation technique for being able to move something, a node, from one place on the screen to another over some given period of time. But then we are setting an on-swipe right event on that node. We want to be able to catch when the user swiped to the right. So we're passing in then a lambda with the event, and then the functional part of the lambda is that we are going to execute the translate transition and make it move over and take 1 second to move over. And by the same token, we can set swipe left and swipe down. The scroll gesture is one in which the user drags their mouse or finger in any direction, and as they're dragging it around, it's scrolling. So here's an example of that. And scroll around. Those scroll events are continuously generated, and they are reporting the XY position-related info to the application. It can either be pixel-based or character and line-based. For example, if I were scrolling vertically and I had text, I might want each scroll movement to be the height of one line of text. Also, they have the ability to support inertia. So if somebody clicks very quickly, then even after they've taken their finger off the screen, if I'm interested in inertia events, inertia being true, then it'll continually report events and trail off using some type of physical algorithm. So to handle the scroll gesture, when the user puts their finger on the screen and starts scrolling, that triggers a on-scroll started event, and here we're passing in a lambda for that, and then we're capturing the current X and Y position. And then as the scroll events come in and are continuously reported, it will be reported to the set on scroll event, and then that gets passed in, and we take the current position and add it to the total change of X and Y, and then we set the current position to that. And that's how we can keep the node positioned where the user is scrolling it. Then we have a rotate gesture, and I'll show you an example of that, where we can take 2 fingers and rotate. So like the scroll event, it is continually generated, and we have angle-related information sent to us. So here, when it starts, we look at the current angle, and then as we receive rotation events, then we take the total angle that was given to us, and then we add it to the current rotational angle to then compute the angle that we should show the node at. And then finally, we have a zoom gesture. I'll go ahead and show you again this demo, the same demo. And as I put my fingers apart wider and closer together, we can see that it zooms. And the code for that is very similar, in that we are catching when the zoom starts, and then we get the current scale, and we make note of that, and then as the events are continuously reported, those get passed into set on zoom, and as in the form of a lambda, and we take the events, and then the functional part is we set the scale, taking the total zoom factor that was associated with the event so far and multiplying it by the zoom factor that we recorded when the event started. Then we have touch events and touch points, which are a lower level kind of idea. The gestures that we just talked about were kind of a semantic idea, the higher level idea, but if we want to control things at the touch event and touch point level, then you can certainly do that. So there are 4 types of events that you can catch. There's pressed, released, moved, or stationary. And then each event has one or more touch points based upon how many points were touched. So here's a demonstration of touch events where I'm touching the screen with one or more fingers. And as I move my fingers or lift fingers, we can see that the polygon is updated. So I'm closing the demo. Here's the code behind that. We've got 3 events: set, touch, press, set, touch, release, set, touch, move, that each take a lambda, and the argument into the lambda is an event, and then the functional part is we're calling update poly, passing in that event. So the code for update poly takes the touch event and then gets the points from that event. It gets the touch points for that event. But before that, it clears the points in the polygon. Iterating over the touch points in the event, it then adds each one of those points to the polygon. And that's why we see that's why we get the behavior in just a few lines of code to be able to track and to show a polygon that connects all of the points that we're touching. So something that was added to JavaFX in 8 is 3D. And so the engineer that I referenced before, Jasper Potts, has a quote that I like to quote, and that is that JavaFX 3D gives you the ability to use 3D geometry, cameras, and lights in JavaFX. So the 3 ideas are the geometry, the shapes, the camera, that's how you can view the scene from somewhere in the 3D scene, and then lights, how you can light up the scene. So first of all, 3D shapes. We have 3 different shapes: box, cylinder, and sphere. Those are the primitive shapes. And then you can create any kind of user-defined shape using triangle meshes and mesh view. So here's a quick demonstration of a couple of the primitive shapes. Here's an example of the sphere and box primitives, a little application in which I can drag using the multi-touch API. I can scroll here and make the sphere and the box rotate around each other. You'll notice that we have some lighting shining on both. The code behind that is here, where we're creating a fun material. So it's a material that is shown on the primitive. And then we're setting the diffuse color of the sphere to blue. The diffuse color is the non-shiny surfaces. And then the specular color, we're setting to light blue. That's where the light is reflecting. And so between those 2 colors, then the lighting will then give it the appearance that the light is coming from a certain direction and then making part of the surface lighter than the other. Then we create a new sphere, giving it a radius of 200, and then we set the material onto the sphere. Spawn material has various different properties. We've seen that we can have a diffuse color, but we can also have a diffuse map, and that's simply an image that is wrapped on the surface of a shape. Then we also have a bump map, which is an image that appears to have bumps in it. It really doesn't have any bumps in it in the physical geometry, but it has the appearance because of the image itself. So here's an example where Duke's nose has a diffuse map texture. There are no bumps on that image. But then here's an example where we're using a bump map texture, and the image gives it the appearance of bumps. So there's a technique called UV mapping where we can take an image and then slice it up and then put it on a 3D model. So in this example, we're in the lower part of this page, we're going to take a Mercator projection of the Earth in an image, slice it up, and then put it on a sphere. So here is an example of that, an application for that. So there's the Earth, and I can take my finger and scroll it. And the code behind that, much like we did with the other sphere, we're going to create a found material, but in this case, we're going to associate it with a diffuse map, which is an image. And we're creating a new sphere with a radius of 400 and then setting the material onto the sphere. So the third thing that we talked about, one was 3D, for 3D ideas, concepts. One was 3D geometry, the other was cameras, and the other was lights. So I'm going to discuss lights here. Lights are the ability to light up the scene graph. You can either do it with a point light, one or more point lights, in which case you have some directional kind of lighting. And you could also use ambient light, which makes it so that the scene just has this general lighting that doesn't seem to come from any particular direction. So here's a demonstration of lighting. First of all, we have a cylinder that we're going to make it move in an animated fashion. Then we have a couple of lights. One of these lights, we're going to move around the scene graph, rotating around the cylinder. And the other one, we're going to have it be stationary, but changing colors. So we can see the effect then that the lighting has on the cylinder as it's moving around and changing colors. The code behind that is on this slide. We're creating an instance of a point light, giving it a color, and then we are positioning the point light at an X position of 700, a Y position of 200, so X being horizontal, Y being vertical going up in the positive direction, and then Z setting it at a negative 200, where positive is going into the screen. So this particular light that we're creating is actually behind the scene a little bit, shining into the scene so that we can light things up in there. And then also we have a camera. Cameras give you the ability then for the user to have a perspective into the scene. So here we're pointing the camera from a position of a Z of negative 10. So again, slightly behind the scene. And finally, we have embedded support. The Internet of Things, or IoT, is becoming a very popular thing, and Java is something that is becoming more and more popular in powering the Internet of Things, running on more and more platforms, running in smaller and smaller microprocessors, and being associated then and powering the Internet of Things. So JavaFX is included in Oracle's implementation of embedded platforms like Java SE8. It's not only available on x86 and x64, but on ARM processors. And then there's also a Java SE Embedded 8 on ARM. And the Java SE Embedded 8 has a subset of the JavaFX features. Most notably, MediaView and WebView are not supported in Java SE Embedded 8. So that concludes my talk on new features in JavaFX 8.
Thank you for joining us. Join in the conversation. To learn more, follow us on Facebook, Twitter, and the links provided.